about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome. Very special guest today. We are going to be talking about developing Reaper extensions, Rust. It will be a lot of fun, and also MIDI management, I think. So with me, straight from Germany, is what you're probably going to know as helgoboss, but his actual name is Benjamin. Hello, Benjamin.
Hi, Leandro. Hello, everyone.
It's very nice to have you here. Thanks for accepting our invitation. So, first of all, before we talk about Relearn, about your other projects, and about Rust, for people who just know your projects and don't know you, can you tell us a bit about yourself, how you got into music, into programming, what got you into Reaper, why you decided to build the extensions you built?
Sure, yes. At first, thank you for the invitation. Very nice to be here, and also thanks to X-Ray for suggesting this interview.
Did you watch when he was over?
Sorry?
Did you watch when he was over? We talked to him 1 or 2 or 3 weeks ago, something like that.
Yeah, something like that. No, I didn't have any contact to him since then. But I'm a big fan of Reaper, and I love to write extensions. I also sometimes write rescripts or JSFX, but it's mainly extensions. But it's not the only thing I do as a profession. I also occasionally work for companies, to make a proper living. And the work I do for them, it's totally unrelated. It has nothing to do with audio. It's more like, Java backend development, like sometimes some software architecture consulting, things like that. But to be honest, what I really love is writing software for music production.
I can relate.
So I'm quite happy that there's Reaper, which is a super nice platform, for writing software. You asked about music, how I got into music, I guess.
Are you a musician yourself?
I am. I don't do it professionally, but I have been doing it since ages. Like, I started when I was 5. Like, my grandmother, she had an upright piano in the garage, and I just played it, whatever comes to my mind. And a little bit later, I also took lessons, like a pretty long time. It was more like classical music until I was 18. And then there was a big decision, like, should I now study music, or should I more study computer science? And well, of course, I made my decision. I didn't study music.
Exact same story over here. I can totally relate.
Funny.
What made you decide for computer science instead of music?
Why? I really loved both. Like, I loved both the same way. And with music, well, of course, you always hear these things like you cannot earn that much money with music, or it's pretty hard. this was probably also a factor, but there were also other factors. For example, whenever I made music, I was very quickly exhausted, like hearing the harmonies. Like I could not practice a long time the piano. It was mostly 1 hour or 2 hour. I could not imagine practicing like 5 hours, like some students do. This was one reason. But I really never stopped making music. I just stopped taking lessons. And so I played in a lot of bands. And later it was more like solo piano. I composed stuff on the piano. And in the recent years, I mainly did silent film accompaniment. Like, you have a silent film playing and you improvise or play your own compositions on the piano while the film is playing.
Interesting. So you're doing that with classical films, not with maybe modern productions that are silent? I don't know if those are a thing.
I'm also not sure. I did it with very old movies, like the 20s, 30s maximum. Yeah, and fun fact is that's the reason why Relearn exists, because I need that. There are so many things you can do. I wanted to have a lot of control over the musics and not just play keys. So there were also sound effects and everything. And that's why I wrote Relearn, by the way.
Interesting. Okay, so what was lacking in Reaper that you wanted to extend?
Well, at first, I tried to do it with the Reaper means. For example, there was a lot of things I wanted to control. For example, the volume of a track or of an instrument that I'm playing, or some effect send volume, but I didn't want to control the whole thing. Like I only wanted to control the range between 50% and 100%, for example. And of course, this was already possible to do, but you had to put a lot of effort into it. You had to somehow pre-process the MIDI messages. You had to use some VST, some Reaper extension. It's called, I think, MIDI to control path or MIDI to control path, something like that. And it was possible. That was a good thing, but it was too much effort. Like for a musician, I quickly want my mappings. I don't want to dive into technical things, because this totally takes the emotion out of it. I want to reach the goal very quickly. So that was the thing.
Yeah, and there are precedents. There are other DAWs where you can just click around and say, I signed this to that, and it's a very fast workflow.
Mm-hmm. Probably, yes. But I don't think, at this point, I think I can imagine that Relearn is pretty unique, that you cannot, because I kept adding features and the things you can do with it. I'm not sure if you can do them in the other DAWs just like that.
Yeah, well, you can do the basics, I would say.
The basics you can do. Yeah, that's true. Yeah.
Right. So you had this need and you developed an extension, but how did you learn about the Reaper extension mechanism and how to get around the API and everything?
Yeah, well, that's a longer story. Actually, Relearn was not the project that I wanted to do first. I had another idea. And before that came Playtime. But what I actually wanted to write for Reaper is something else. So maybe I can tell you a little bit about my DAW history. I started with Cakewalk back in the 90s. Not sure if you know that. It's later it became Sonar.
I heard about it, but I have never used it.
Yeah, it's at first. So I only did MIDI things with it, and then later I changed to Cubase, and that's where the audio stuff came where I also started doing stuff with audio, and I was quite happy with that because I mainly did arrangement and composition and stuff. So I used it for around 10 years, but I was also playing in a band, and I always liked the idea of using the laptop on stage. I wanted to use this power, like VST instruments, VST effects, and all that stuff. I wanted to use it on stage. So once I just took the laptop into the rehearsal room, but it was terrible because there are a lot of people in the rehearsal room, and the best thing is if you just play with them and interact. But I was totally that day I was just looking on the screen. I was kind of I used my mouse, I used the keyboard, and I couldn't concentrate on the music itself. That was the point. So I was then looking for a software which allows me to quickly create sound setups and switch between them very quickly, so that so without having to use the mouse, without having to use the keyboard, and maybe not even the screen. So that was my goal. And that's when I started looking into other DAWs, because Cubase was not really, it couldn't do that. And so I looked into Energy XT, and I realized there's nothing like that. So I wanted to write it on my own, but I didn't
Famous
want
last
to...
words. How hard can it be?
Yes, so I was thinking about a standalone software, but it's not that cool. It's nice to stay in your DAW environment, I think. So to have some kind of plugin, that's better, more user friendly. And I also didn't want to make a VST instrument or something like this, because what I wanted to do, it's not an instrument, it's also not an effect. It's more like a workflow enhancement. And, I could have done something like, complete control, which is essentially a plugin, which is also a host. But I don't like that. I think it's a hack, because the integration into the DAW is not good, because you only have the audio channels, the MIDI channels, but you cannot integrate it in a better way.
Interesting. I have never used it. I know of it, but I didn't try it.
Yeah. So I didn't want to do something like that. And then I looked specifically for a DAW which I can extend, something which can act as a platform for my own ideas.
Reaper is the perfect DAW for software people.
Yeah. If you do that, then you automatically arrive at Reaper, because there's nothing else that allows you to achieve this amount of integration. There are some DAWs, they give you some scripting possibilities, but not even something like Rescript, and for sure not extensions.
Yeah, depending on the DAW, you cannot even have custom keyboard shortcuts, let alone custom actions, let alone something like a Rescript.
Yes. So that's when I arrived at Reaper, and I read a lot about the SDK and so on, and I realized it's not just a good platform for programming; it's also a good DAW. So I changed from Cubase because I really liked what I think everybody likes about Reaper. It's so snappy, and it's minimalistic, but still it offers you a lot of features, but they are just hidden most of the time. But if you need them, you can just access them using the Actions menu. I really liked that workflow. So and then I started making a prototype of this thing. I think it was in 2013, or the software that I wanted to do. And I quickly realized it's too much. Like the project is too big, because I needed to learn too many technologies, because I wanted it to be an app actually, which connects to Reaper, and then you can control Reaper from that app. And
Okay. And
it
how would
was
the
just
communication work? Would you use the web interface? Was it a thing back then? I don't know.
not yet, but I did it with WebSockets. So WebSockets that, or just sockets, like both would have been possible, TCP sockets, and it worked. But at that time, it was hard to do cross-platform mobile development. It was 2013. I felt, oh no, now I have to develop this thing once for Android, once for the iPhone. It's too much, and so I thought, but I thought I saw already what the Reaper API is capable of. So I thought maybe I can do something else just to practice. So I did playtime because I realized it's also something I was missing a little bit. This possibility to work a little bit like in Ableton Live. So I thought, okay, a lot of users somehow wanted that, and then I just started because this is not so difficult compared to the software that I wanted to write before. Yeah.
Right. So you just had to read the docs. There are not too many of them. There isn't a lot of documentation, but you just work your way through the little documentation that there is on the Reaper API. And you wrote all of that in C++, right?
That's right. Yeah, so it was a bit reading documentation, asking on forums, asking Justin, and yeah, so and the most of it was try and error. Like I had to test all functions. I was not used at all to programming in C or C++. So there were a lot of new things. And exactly, I did it playtime, and also the first version of Relearn, I did that in C++.
So you could write Lua scripts to do some things in Reaper, but you had to go to C++. So what are the limitations? What is something that you cannot do with Reaper scripts and that you can do with the extensions in C++?
Yeah, first, I wanted both playtime and Relearn to be a VST instrument, a plugin that I can just have many instances of. Because I consider both of these plugins actually as instruments. Playtime is an instrument to play loops, and Relearn is an instrument to play Reaper itself. So I wanted them to be instruments, so they also should be able to capture the MIDI stream. I wanted to do stuff like, yeah, it was mainly about being able to capture the MIDI stream of the track, and that was not possible.
So you wanted to insert yourself in the signal chain, in this case, the MIDI signal chain. Mm-hmm. And the purpose of having multiple instances is so that you can configure them differently. So perhaps you change the routing of the MIDI and the controls change.
Yes, things like that. And of course, I also wanted it to be like a product. It should feel like a product. It should not be some random script that you hack together, but it should have this product character. And I didn't want to run into potential performance issues, so I chose a native code.
Right.
Yeah, I think that's the reasons. And also, I mean, I like Lua. I like it a lot, and it's good for scripting. But I prefer statically typed languages. If I write a big application, and at least Relearn is now really very big, then I prefer static typing. I want the compiler to help me. And the scripting language doesn't have one.
Yes, right. Okay, so do you think you succeeded? Do you think that at this point you can go and rehearse and just have your laptop, but don't look at the screen and don't use your mouse?
Partially, yes, but the thing that I wanted to create, it's not there yet. So playtime was like a distraction at first. Now it's not anymore, but it was a distraction. And relearn makes it possible to some degree, but not in the way that I envision. So actually, my plan is to to bring out Playtime 2, and Playtime 2 will have an app. It will be, you can run it on the desktop, you can run it on the tablet, and it communicates with Reaper using gRPC, and yeah, so you have an app. So this is very close to what I wanted already, but and I think I'm just going to add more functions to this app later, so that Playtime isn't just an Ableton Live session view simulation, but also the thing that I wanted, like a possibility to quickly build sound setups and to switch between them. A little bit like, SWS Live, what's the name? Live sets or something? Live configs. Yeah.
Yeah, I
Like that.
remember reading about those.
Much more convenient. Yeah, that's basically it.
Right. Okay. So just want to say hi to people in the chat. Hello, Fatis and Bo and Tail, and perhaps other people who are watching but just not active on the chat. It's great to see you all here. If you have questions, then please go ahead and ask. But I thought that perhaps we could dive into this whole Rust story, because that's a different spin to your extensions. Most people who are using extensions, they are doing it in Lua, or I guess Reaper scripts, they're doing it in Lua. Then fewer people are doing things in C++, and you are the only person I know of who is doing stuff in Rust. So tell us about it. Why did you decide to switch from C++, and how's it coming along?
Yeah, so I in 2016 I wanted to make relearn open source, and I didn't just want to publish the source code because it was partially a big mess. So I wanted to use this opportunity to also polish the code a bit. And the first version of Relearn, it was built on, like, it used some library, some C++ library that I wrote myself. I called it Re+. It was essentially a simplification of the Reaper API, where you can, like, more object-oriented a little bit, that you can just very easily go from the track to the effects and so on. Just the Reaper API, but easier to use. And so Relearn very heavily based on it, and I'm happy I did that, because Playtime, the Playtime 1, I didn't have something like that, and I just got much more productive having this high-level API to work with. So this was a very important part. And
that's so interesting. Sometimes it's better to build the tools you find are lacking and then build the thing you want to build, instead of just trying to work and power through the limitations of the existing tools. I really appreciate this mindset of, I think that this should be done in a different way. I will build it myself.
Yeah, exactly. I'm quite happy that the Reaper guys, they have this API, and I think it's hard to make an API that satisfies everyone. So they kind of made the minimum API possible, like putting everything into a function. And of course, that's a bit hard to use, but the big advantage is that they can easily improve it, extend it, without thinking too much about this backwards compatibility story. And I can just build whatever API style I like on top of it. So yeah, that's cool. And but because I had this RE+, I also had to publish this one. I had to publish a library, and I think publish a library as open source is more effort because you want this library to be nice, and you want it to be easily usable and clean, and not make too many breaking changes and so on. So I needed to put a little bit more effort into that, and I was thinking I will do that with C++, and I will use maybe some new C++ features. I always try to use more modern C++, like C++ 11 or even later standards. And I was thinking I would integrate the C++ ranges API, a pretty recent addition. And so I tried it. I went the C++ way. I polished my thing, but at some point, I just didn't continue. I didn't like it. I didn't like what I saw, and there were too many things that I didn't like about this, and it turned out to be C++. I didn't things like, for example, like it's pretty hard to already set up a working development environment. Things like that. I'm coming from languages like Java or JavaScript. There you have Maven or you have npm, and you just execute one command, and it downloads all the dependencies for you, and it just works. With C++, it's not that way. And I already tried to migrate everything to VCP package. I'm not sure how it's pronounced.
Yeah, I know of it. There are plenty of tools in this space. There is Conan.
Yeah,
Well,
exactly.
there are several.
Yeah, so this made it a little bit better, but it's not even close to what to this simplicity that you have with Maven and npm.
But it's also the case that I feel like in C++ projects, people tend to bring in fewer dependencies and they are more curated. And I agree that the ergonomics isn't there, but it's not like in JavaScript where to get anything off the ground, you start by installing 100 dependencies.
Yes, but I wanted to be productive. I didn't want to go without dependencies. I don't want to reinvent the wheel. So I definitely had dependencies. For example, something to serialize things as JSON, stuff like that. And but a lot of more, and some libraries were really good, and other libraries were really they had this they didn't use modern C++. They more used this old style, and this is also something I didn't really like. There were very, very different styles. It was not the same. It was like having multiple languages, working with multiple languages at the same time. So this is just a few reasons, but there's also like
Truth be told, the same is true of JavaScript. There is the callback universe versus async await, and there is require versus ECMAScript modules. So,
yes, true.
It's the price of, I guess, moving forward, right? If you want to make things better, you will have to introduce a new style, and then it takes a long time for everyone to migrate.
Yes, that's true. But then also other things, like I never liked the iterators in C++. When I was used to iterators that you can use, like you have these things like map, flat map, filter. I used these a lot, and not having them in the same way in C++, I was always missing that point, and I was hoping that the C++ ranges API would bring this, and I think it did bring this, but at that time it was pretty new. Like there were not so many tutorials about this. The documentation was not so good, and I had also the fear that it works in one compiler for Windows, for example, but it doesn't really work on the other platforms. Things like that. It was yeah, just too many things. I could also name more, but I think it would get boring. Yeah, so at that point, I thought I heard about Rust, and I thought, okay, maybe I can just give it a try. I have nothing to lose. I had some time to spend.
And if it feels like you're working in multiple languages anyway, might as well work in multiple languages.
Yeah, exactly. So sorry, I have a cat and she wants to go.
Well,
out.
I have a baby.
I'm back. So I thought there's nothing to lose. I can just try it in Rust, and it was hard because I had to start from the scratch. Like I started with this library. At first, I had to find a way to even talk to Reaper from Rust, and these were the very basics. But so I made some prototyping, but I realized it's not that hard. So it was working, and I knew if this works, then I can build everything else on top of it.
But hang on, before we get into these bindings, there could be other languages you could use, right? So did you look into other languages, and what made you decide for Rust?
There are not many other languages I could use because I had a very strict criteria. I wanted it to be not garbage collected.
Okay.
I wanted a language where you do the memory management yourself, because I also have parts in relearn that run in the audio thread, in the retime thread. I don't want to use a garbage collected language.
Fair.
So yeah, and that turned out to be a good choice, because more and more things I do, for example, for the playtime clip engine, they run in the retime threads. So something like Java, for example, in the earlier times, I always wanted to use Java to do everything. It was a little bit a stupid idea because you always need a virtual machine, and you and you have this garbage collection, which is always like most of the time a deal breaker if you want to do real-time stuff.
Yeah. Okay.
So that's why only Rust actually.
Many people are gravitating toward Rust because of that in the audio community. Many people are interested in Rust because of this, I guess, design choice of being close to C++ in those aspects, like the garbage collector, while still giving you extra stuff. So tell us about the things you like about Rust.
Yeah, well, essentially it solved all the issues that I had with C++. For example, you have this things, the tool landscape for Rust is very, at least at the moment, still everybody uses the same tools, kind of. Like there is, and these tools are very good. Like Cargo is a build and dependency tool of Rust. It just works, and you can very easily pull in dependencies. So there's not much you have to set up. Then the IDE support, it gets better and better. And then you have, I really like the standard API of Rust. It's very consistent. It's very consistent, feels good. I finally have proper iterators as I know them from other languages. What else? Of course, the main selling point of Rust. I was not even particularly looking for that. But when I started learning Rust, it came to me that that Rust is just more safe. Like with C++, it's super easy to write code that works now on your machine and doesn't work at all in a specific point in time. Like,
yes. For more about this, people can watch my previous meetings of the C++ study group, in which I'm working on this effect that works 50% of the time, and 50% of the time it crashes Reaper.
Yeah, exactly.
And it was as simple as I think that the issue was. I was not initializing a member variable. So something as simple as that broke everything, and Tail caught the mistake, and I fixed it, and so far it hasn't crashed again. So I think that was the issue. But who knows?
Yes, whenever I compiled C, I always had this a little bit bad feeling here. Will it work or will it crash Reaper? And you know, for some applications it's okay if it crashes, but for applications, for plugins that should learn that should run somehow in a live environment, maybe you play live on a stage, no, it shouldn't crash. And Rust actually helps with that because it prevents some bugs like right at compile time, just because of the way it's designed. It's a little bit a different story because the thing that finally runs, it's not just Rust in this case, because it's also Reaper, and maybe I could still have some mistake, some bug in my bindings on the way I use the Reaper API, and it can still crash. But I used a little bit. I used some ways to somehow prevent that, if possible, like to rather write an error message on the screen instead of crashing. Yeah.
Right. And do you ever feel limited by the Rust compiler? Because one of the disadvantages of having a strict type system and all the facilities around it is sometimes you're just trying to write something that is incorrect from a type perspective, but you know what you're doing. So you're just like, please stop. This is something that comes up in TypeScript a lot. I'm writing something that I know is wrong, but I can always say to TypeScript, shh, I'm doing my thing. I'll get back to you. And I really like that about TypeScript, but in other languages, you sometimes feel limited by the security. You'd like to turn things off from time to time. Do you feel that about Rust? Do you feel that sometimes it's too constraining, all the ownership types and having to deal with all the infrastructure that comes around that?
Sometimes, yes. And in the beginning, I was hitting some limits quite often. Like I thought, why can I not do it like this? And then mostly Rust complained about some lifetime issues. But a lot of times it turned out that Rust is correct, and I just didn't see it. And at other times I knew, okay, I could do it, but I just somehow have to prove to the compiler that I'm right. So I have to kind of rewrite my code, and I had to do that a lot in the beginning. But you know, the more often you do this, the more used you get to the way you write code in Rust. It somehow pushes you into a certain coding style, and now I'm so into this style that I'm not limited much about these from these constraints that Rust puts on you. So it was more a problem in the beginning. Now it's okay, but occasionally I still have some situations in which I wish I just shut up.
Trust me on this one, compiler. I know what I'm doing. And then it crashes. Yes. And then it's like, yeah, okay, compiler. I trust you more now.
Yes. I mean that there's maybe you have heard of the unsafe keyword in Rust, which lets you do a few things that you cannot do without unsafe. Like for example, you can if you have a pointer and you want to dereference it, then you can do that in the unsafe block. In the not unsafe block, you cannot do it, for example. So an unsafe means like just here, dear compiler, I know what I'm doing. But still, you cannot do everything in the unsafe blocks. There are still certain limitations.
And the way that I understand it is also a way of overcoming some limitations of the language. I remember back a couple of years, so probably things have changed because Rust is evolving fast, but there were some things you were just not able to do. I don't remember examples, but there were some things you would not be able to do. And the solution was, yeah, for this, you go into unsafe mode and you do it. So it was also a way of answering limitations of the language when the designers were not really sure how they wanted to do something. They would just say, okay, for now, you do it in this unsafe way. In the future, we'll have a better answer.
Exactly. It's sometimes like a fallback. And these Rust guys, somehow they are very, before they mark something as stable, they go through a lot of discussions and many things make it into the nightly version of Rust pretty quickly. And at the beginning, I actually always used nightly Rust because I wanted to be on the cutting edge. But later I realized it's better to use stable Rust because things break less often.
Hence the name.
Actually, yeah, exactly. So now I sometimes also use such fallbacks, but now I cannot think of one. The thing is, I have to use unsafe pretty often because, at least for the REAPER bindings, there's no other way for sure, because you need to talk to a C API, and there you just need to use unsafe.
Yeah, tell us more about these bindings, because you were telling us about how they work essentially. The simplest basic thing of how can you talk to a C and C++ API, the REAPER API, from a different language.
Yeah, maybe I could share my screen.
Yeah, of course.
So can you see C Lion?
Yeah.
Okay. So maybe
do you use C Lion because you are used to the JetBrains ecosystem from working with Java?
Yes, so I'm super used to it, but yeah, from that time, yes, Java or the other one, WebStorm. Yeah, so I'm just very used to the JetBrains IDEs. That's why I use it, and it also works very well with Rust. So I actually made an extension that, and I think this is a good starting point, like an extension that uses my Rust bindings, and I will just walk you through it a little bit. So this thing is also available on GitHub, the REAPER RS Hello World extension.
Awesome.
And yeah, so it has. You can also try it.
So some of your projects are open source and others are not, right? The REAPER Rust binding is open source, and Relearn is open source, right?
Yeah, it's also open source.
And Playtime is not.
Well, actually, the biggest part of Playtime, like Playtime 1 is not open source. No, Playtime 2, it's partially open source. It's integrated into Relearn, but the user interface, if you actually want to see something, then you need a commercial app which talks to Relearn, which talks to this Playtime clip engine.
Sure.
So it's divided. Okay. But the core part is open source of Playtime.
I see.
Playtime 2.
And for people who want to support your open source endeavors, do you have ways of doing that?
Yeah, for sure. I have some links on my GitHub profile. So here, or here on the website, there's a place where you can donate regularly or not, or also on the on my GitHub page, mostly the Relearn page. There you have some links where you can donate if you want.
All right. Yeah, I wanted to bring this up because open source is sometimes difficult to make sustainable. So I want to shout out to these other ways of supporting developers.
Yeah, thank you. And that would definitely help. And I started a little donation campaign just 2 weeks ago or so, because I realized it's pretty hard. If you work half a year for a company and not on your own products, then your own products are paused for half a year.
And there's a lot more than just writing the code. You also have to write the bindings that we are going to look at. You also have to do the videos that you're now doing on your YouTube channel. So there is a lot of work that goes around the project.
That's true. So you this is the extension, and there's also README. So you can. This is really everything you have to do in order to make it work. And I tell you a little bit about it. Like maybe you already know Rust. It could help, but I think even if you don't know, then you just have a look on these files. There are not many. It's actually just this one and this. This gives you a working extension. And I will at first we will look on this cargo file. It's like a build descriptor. So you have some information about the package, then the dependencies, and then here you tell Rust that you want a dynamic link library, like SO file on Linux or a DLL file on Windows, dylib on macOS. And
that's interesting. The dependencies are to the same place. They are all pointing at the same repository, but there are different packages in the same repository. Is that what's going on?
That's true. It's different crates, and Rust is called crate, a package. But they are in the same repository. Usually, you don't do that. Usually, you don't directly go to GitHub.
Okay.
But you do like this. This is how the usual way of doing it.
And then it goes in some kind of repository that is well known, right? Like NPM.
Yes, it's called crates.io. But at the moment, I feel that not many people actually use Reaper RS. That I'm one of the few users, and so I don't regularly publish.
Okay. Do you know other people using?
I know that some people sometimes ask questions. Like I would just jump to this repository.
Isn't the internet a great place? I love how that happens. Sometimes I am working on my own thing and I am not even documenting it yet, and some people just jump in and start talking about it, and I'm like, where did you come from? It's awesome.
Yes.
I love it.
Yeah, yes, it changed everything. Like this possibility to like GitHub, so having such a central platform, I love it. And yeah, so there are some people who ask questions, but it's not many so far. Yeah, so that's why I refer, like also on the README you can see that I recommend to not use the version which is on crates.io, because it's a very old version, but instead directly refer to the GitHub repository.
I tend to keep things mostly stable, you say on the
Yeah.
documentation.
Yes, like Reaper Low and Reaper Medium. Yeah, it didn't reach 1.0.0 yet, and it will probably still take some time. But I, I put a lot of framework into this, how to make it, how to keep it stable. It's totally different with a Reaper High, this high level API.
So
This,
these were the levels of APIs that we were talking about before. I guess the low level
Mhm.
API is pretty much the C++ API, but you mentioned how in C++ you are trying to do this more idiomatic API, and that's what the high level API became in Rust, right?
Yeah, actually, already the Medium API is already higher level. Like this is quite idiomatic Rust already. So yeah, I wanted to explain that. Yes, so these dependencies, there are 4 of them, and if you just actually you only need to that the thing that you need at least is Reaper Low. This is a low level API of Reaper RS, and it contains nothing more than the raw bindings. It's a little bit pointless to use just Reaper Low because if we program in Rust, we also want to use a Rust style. We don't want to constantly dereference pointers and stuff, and we don't want to work with C strings. We want to work with Rust strings, and this you cannot do in the low level API. It's just I show you a bit how it looks.
This conversion process between, let's say, C++ strings into Rust strings and then back, does it introduce any noticeable overhead?
I kept it to a minimum. So there is, it depends a little bit. Like there is one, usually it doesn't introduce overhead because Reaper tries to, if you have a Reaper string, it's UTF-8 encoded internally. Usually, like sometimes you cannot completely rely on it because some plugins don't use, for example, don't have UTF-8 names, but it's very rare. So I put quite some thinking into it, how to make this without overhead or almost no overhead. There's this, let me see. It's a medium level API. The string types, and I wrote as a note to myself also a lot about these design decisions, and so it's not completely without overhead, but it's all it does is sometimes checking if it's really UTF-8. That's it. But
Okay.
in many situations you can avoid the copy to make a copy of the string.
Okay. So you're just checking if it's okay to look at the same data in a different way. And if it is, then it's just the cost of checking.
Yes. You could even turn off that checking, but one goal of this medium level API is also to make things more idiomatic. And one thing that is very idiomatic for Rust is to have safe access to methods, so that you don't have to worry, is it now going to crash Reaper?
How often do you crash Reaper using Rust?
Fortunately, not very often. Like it really, it's much less than in my C++ times, because I worked pretty much. I worked a lot on making it somehow safe. Like not all functions are safe. For example, if you look into this list of medium level Reaper functions, then some functions I could mark as safe, or well, you don't write unsafe in front of it, and then you essentially cannot, when you used it, you cannot crash Reaper by using that. But there are some things which I could not mark as safe. So there's an unsafe in front of it. Then this is like an indication, okay, you have to take care. You cannot just put any project pointer here in this project context. You need to take care.
And I see that you documented that Reaper can crash if you pass an invalid project.
Yes. So this medium level API, it can only do so much. But wait, I wanted to talk about the low level API at first. We will later move on to the medium level API. The low level API is essentially this Reaper plugin functions. Whoever wrote extensions in C++ will know this file. It's essentially as a collection of function pointers, and
it's
Reaper,
also familiar for people using Reaper scripts in Lua.
Yes, because it's mostly the same functions. Not all functions are available in Rescript, but most of them are.
Yeah, I recognize some of the names in there, like add take to media item.
Exactly. So, and the Reaper, the Reaper as low-level API, it looks very similar. You have a Reaper file, this thing, and it has the same functions, just written in Rust.
Okay.
And they delegate to C. They delegate to Reaper. They just call the Reaper functions. And this file is completely generated. So there's no there are no manual parts in this. So whenever Cocos decides to add a new function, then I can take this generate this Reaper plugin functions header file from within Reaper, and then regenerate the bindings, and then you have the new functions available.
Right, and how do you do this automatic generation? Can you tell some Rust tool to look at a header and generate the file, or do you have to write some macros to do that for you? How does that work?
Yeah, so the first step is using a tool which is called BindGen. It's a Rust tool that allows you to generate bindings, Rust bindings for C libraries. It looks on it basically parses C header file and generates Rust from it. So it's called so it generates the bindings for a foreign language interface.
Mm-hmm.
And this is only the first step. Unfortunately, if one would just do that, then many things wouldn't work. And so this is a build file. It's not so big. Like it's 1,000 lines of codes.
That would generate, I guess it was 20,000. So good ratio there.
Yeah, exactly. I'm not sure how much is how many. Yeah, 23,000.
Yeah.
Yes, so a little bit more has to be done. So you also have to parse the result that BindGen creates. But fortunately, there are packages in Rust that you can use to parse Rust code and then modify it. So it's not just using BindGen, but it's okay.
Okay, so you essentially write code that massages the abstract syntax tree of some Rust code.
Yes.
Interesting.
And transforms it into this. And I've chosen a little bit different approach than Cocos. Like if you look at this, you see it's function pointers, C function pointers, and they are assigned. They are just static. You can access them from anywhere. They are static, and as soon as your plugin is loaded into Reaper, then you can be sure, well, almost sure, depending on the version of Reaper that you are running, that they are assigned, so that you actually can call this function. And having static variables, for example, function pointers, is not very common in Rust, not at all. Like, so I decided to put it into a struct. Let's see, this is a struct, it's called REAPER, and it has the function pointers in it, but it also allows you to call these functions directly. So if you have this low-level API, then you can essentially write in Rust as you would write in Z. For example, I will just show this. This way you access a low-level API, and then you can call these functions, but it's not very developer-friendly. Now you have to pass a C string. There is a void pointer, which is very unusual to have when you write Rust. So clearly, just this low-level API is not enough. It's good to have it because everything else can build on top of it, but yeah, it's not enough to write Rust in a satisfying way, and that's why I additionally put.
When you bring this up, I'm thinking of something, and that is, I agree that it's not idiomatic of Rust, and I'm also going to say I don't really like the API in Reaper a whole lot. I love that it exists, and I love what we can do with it, but it is not aesthetically pleasing for me. I don't love the way that the code reads. So I appreciate the effort of creating some other API on top of it. The downside, of course, is that now anyone who is interested in building a Reaper extension has to learn. I think there is no way of avoiding. They will have to learn about the low-level API, because at some point they need to know what are the capabilities, what can you do with the APIs. And this is what everyone is going to be talking about on the forums, because most people are at that level. And,
yes.
and then there is the other thing that people have to learn, that is the high-level API. So do you ever think about this? Like, perhaps this would be more idiomatic, but it's less familiar to people, so we'll do it this different way.
Yeah, it was a thought, and that's why I created not just one API, which is a little bit higher level, but two. And there is this low-level API I explained to you. The medium-level API is designed to be extremely close to the low-level API. Like the function names, it's essentially also just a list of functions. So, and they have the same names. So whenever you know something about the original C function that you find in here, then you just need to look up the same function name in the medium level API. Let's see something that exists, because the medium level API is not complete. For example, on pen change, and if I look for this in this medium level API, then I should find it there.
But the medium and the high level APIs were not generated automatically. You wrote those.
No. I wrote those because you cannot just generate idiomatic Rust. You need to think a little bit about it.
Yeah, because it's doing more than just converting from C strings into Rust strings automatically, right? It's doing treating the void pointers, all those things that we talked about. But I see that you also changed the naming convention ever so slightly. The capitalization of control service on pause is different.
Exactly. So I only wanted to make it feel idiomatic in Rust, but I didn't want to change the function structure. I just wanted that you look into the official Reaper documentation, and then you can have a look here, and it will feel very familiar.
Yeah, I guess it will be satisfying for people who know Rust and know the API. They will probably read the documentation and be like, I wish that this worked that way. And then they would go to this file and see, yeah, it does work that way. Great.
Yes. Sometimes it works a little bit differently, but I try to to keep it really very similar, like also the parameter names. But of course there are also some things that I changed. For example, in Rust it's very popular to use so-called new types that are just wrappers, like zero-cost wrappers around primitive data types. So, and this is very convenient. It's very ergonomic to have to know that from this function it really returns a BPM value. And because sometimes Reaper.
So that BPM thing was just, it is a number. It is not an object that contains a number. It is a number. But you are saying that this number is called a BPM. So now probably the type system will do special things if you try to assign a BPM to another number that is, I don't know, a frame rate.
Exactly. This will be prevented because you have this type.
Okay, and F64 is probably floating point 64-bit, right?
Yeah, it's a double in Z.
Okay.
In C++. Yeah, but internally in the memory, it's also it's just a double. This exists only at compile time. This BPM.
Nice. It's one of those free abstractions.
Yeah, exactly. So I change things like this, or often in Reaper you have, in the Reaper SDK, you have numbers, like magic numbers, that stand for some kind of variant. Like, let's see. For example, there's this fx add by name function somewhere here. And internally, you have to this is a low-level API. This one, then you have to pass an integer, and here you have to pass a bool and so on. And this is also very uncommon in Rust. Usually, you have code that talks to you, like. You just need to read it, and then you don't have to look up much documentation, and you know already what's going on. That's also one idea of Rust. That's why I used a lot of enums instead of these magic numbers.
Ah, okay. So instead of passing a Boolean, you would pass some enumeration that is explaining what that Boolean would stand for, like. I guess undo behavior could be just true and false, but instead it's an enumeration of the two settings.
Yes, and this is Booleans, but of course there are also the Reaper API has a lot of integers that are special that have special meanings, and there it gets really useful, like to actually see what it means, and it also prevented. Quite some bugs in my own software. I knew I have done it wrong before in C++, but having all these variants and having documentation right in front of you, I found that it's a great help.
Interesting. I really like this idea, especially because it often happens that you think something is going to be a Boolean, and then you learn that there is a third stage, and then you have to either go with an enumeration, or you have to do something crazy like true, false, or undefined.
Yeah.
I like this idea.
Maybe we can try to do something with this API. Like I will stay. Okay, maybe I should first explain the third elephant in the room, the high-level API.
Of course.
This one is highly unstable. It provides an API that I use very often, but I also change it very often. So it's better you don't use it. It's super unstable, and but it provides a lot of more convenience than this medium-level API. I will just show you an example. At first, let's run this this extension here. This is the extension code, and it has a macro here, which just takes care of bootstrapping this extension for you.
Why do you ask for the support email address?
Because this is part of the high-level API, like the code that this macro generates. And the high-level API is very, what word do they use for that? Like opinionated. It's very, it's very subjective. It's maybe not everyone likes it like that. And the medium level is super neutral because it sticks very close to the original API, but the high-level API is what I need in my plugins a lot. And I have this this arrow screen whenever something happens that is not supposed to happen. It's called panic in Rust. Then it will print an error screen here, a bug in the software, and it will print the name, and it will also please send this stack trace to this address.
I do exactly the same in one software that I built called CourseLore, which is my day job. So I do exactly the same thing.
With an email.
Yep.
Yeah.
But it's a web application, so completely different space, but still same story. I ask for an email address that people can report bugs to. And it's a screen that is never supposed to show up, but when it does, at least it's friendly. So you're saying that this is opinionated, but I agree. I am of the same opinion.
Okay, then we have the same opinion on this. That's good. But if you want, you can go without it. Like this is just a macro. If you want, you can always use a lower level API and do it your way. Like this was one major design idea of Reaper IS, that you can always go to lower APIs and do it your way. Yeah. So then here it's a little bit like a main function, and this is a way in Rust how to say, okay, the result of this function, it actually doesn't have a result, but it can have an error. For example, if there's an error bootstrapping your plugin, then you just return the error, and Reaper will not load this extension. And then we have it's actually a high-level API entry point, so we can at any time get access to the Reaper instance, to this struct. And from there, we can access all the functions and everything that the API provides.
Including getting lower level APIs.
Yeah, exactly. So the first thing which I do here is navigating down to medium Reaper. It's a medium level API. Because, as I said, I don't recommend to people to use the high level API at the moment. So we immediately go one level down. There's also another way to do this. Here, this is the documentation of this macro. You can also use it like that. This is much less opinionated. But you have to create the Reaper session yourself, and you also need to make sure that it stays in memory. So and this is a bit inconvenient. certain things in the Reaper API, they need to stay in memory, and usually in the C++ world, you just make them static. But in the Rust world, that's very uncommon and also not very comfortable to work with that and considered unsafe. So I just wanted to lift this responsibility from developers, and yeah, you just need to call reaper.get and then you get an instance automatically. It's cheap.
Okay. Under the hood, is this using a static variable?
Yes, but you abstract it away. You just you make sure, for example, that it's already initialized and so on. Like it's safe.
Okay.
Yeah, this is the thing you often have to do if you communicate with a C API. You use unsafe yourself, but you expose this function. You just make sure that nothing bad happens, and then you expose it as safe.
Nice.
That's the way. So, and it just calls the show console message function, and we are going to run that.
I have a question about syntax. Yeah. It's bugging me. Line 9 doesn't have a semicolon at the end. Why?
Because Reaper is an expression. No, Rust is an expression-oriented language. That means everything is, well, I'm not sure if everything, but many things are an expression. And if you just want to, like, you could also write this. It would be the same, but it's not idiomatic at all.
Oh, so the semicolon is really saying I am separating expression on the left from expression on the right. And if you put a semicolon there, the thing on the right is nothing. So that's why you need the return keyword there.
If you, like, for example, if you do this and you put a semicolon there, then, well, the right side is something. It's this expression, and you will...
no, I was saying the right side of the semicolon is nothing.
Yeah. Yes, exactly. If you put a semicolon, then the result of this expression, it will be the unit type. The unit type is a little bit like void.
I see. Okay, I get it. Yeah. Kind of weird, but now that you explain it to me, it makes sense. Funny though, because it is not just punctuation. The semicolon actually has semantics. Interesting.
Yeah. Yes. I've seen similar languages. For me, it felt quite familiar. I think I used Scala. I think they also do it that way, and other languages. So this felt quite familiar.
Okay. I am familiar with languages that don't do this exactly. Like, for instance, in JSFX, you put the semicolon on the last line if you want. It's optional, but you can if you want. And I always do, because if I want to reorder lines, I don't want to have to remember to put semicolons here and remove from there. And I even like trailing commas on my arguments when they span multiple lines. So the syntax looks a bit weird, but I get it.
Yeah, it takes some getting used to. Like when I was not used to the Rust syntax, I was thought, what a strange language. But it's always like that. If you start a new language, I started working with many languages, and at first you always have this impression, but then it goes away very quickly.
Yeah, the more you use it, the more you get used to it, so it's fine. And we tend to find familiar things straightforward. So yeah, okay, so you compile the thing, and now can we see it?
Yes, so there's nothing much to see. This is just this extensions. They load whenever Reaper starts. So this hello world message, it will just be printed to the screen. This is the simplest thing I wanted to show you.
So hang on, you're saying that when you compiled on CLion, it created in this case, a dynamic library, but in Windows, it will be a DLL. And it put it in the right folder in the Reaper configuration under user extensions or something. I forget the name of the folder. And then, oh, there you go, user plugins. So
Exactly.
that's the dynamic lib. And you seem to have a custom Reaper installation just for testing things. That's why it's in documents opt. Okay, so then when Reaper starts, your plugin starts, and that function that we were looking at is called, so we see the message on the screen.
That's pretty much it. Yes. So I made it a symlink. So there's output of this. This is the output of the build process. It creates this file, and I just symlinked it over here into this user plugins folder, so it's always up to date. One important thing, if you want to try this yourself, but I think I also documented it, you need to take the lib prefix away. If you don't do that, then Reaper won't do anything with your extension. It will not detect it. It needs to start with Reaper directly.
Ah, and why do you generate a name that starts with lib in your build process?
That's how Cargo does it.
Oh.
Maybe there's some way to change it, but yeah, it's a convention over configuration, and I think in this aspect, they don't provide a way to skip it, or maybe they do, and I just don't know it.
I see. Okay.
That caveat you have to know.
All right. So fair enough.
Yeah, and going from here, I wanted to, if that's okay, I wanted to show you what things you can do which you cannot do with Rescript, for example.
Yeah.
I think that's interesting. So at first, I want to show you a way how to react to certain events in Reaper. Like, for example, the Reaper SDK, it provides an API. It's called iReaper control surface. Let's have a look.
Oh, hang on. I have a question.
Oh, yeah?
Okay. So this Reaper extension, it is like SWS, right? It's not a plugin. Specifically, it's not something that you are going to drop on a track. So it's not like relearn in that capacity, right?
It's not like relearn because I wanted to show something more simple today because it's, you know, if you have a VST plugin which uses the Reaper SDK, then you have to take care of a little bit more things. You have to make sure that when you unload the plugin, then everything is gone. You cannot. You need to enrich. You need to clean up. If you have you really need to take care of that.
Okay, and but you can still do a VST in Rust and include your bindings and all the library that we are looking at. And that's what is done in relearn, right? Yes,
and exactly. Relearn has just another entry point. Like the entry point of this is, let's just have a look into this macro. Macros generate code, and the code should be somehow visible here. Oh yeah, it goes pretty deep. Well, let me have a look. Low-level plugin code. Yeah, it generates DLL main on Windows, and this on and also it generates this, I think, on and this Reaper plugin entry. So every extension developer knows this Reaper plugin entry is the entry point. And if you have a VST plugin, then it will be another entry point. And this entry point will be called many times if it's a VST plugin, but this only once.
I see. Okay. So it's just running in a different context. This is a
Yes.
Reaper extension that is not a VSC, but you could have a regular VSC that follows the VSC lifecycle of instantiation, but also uses your extensions and your Reaper bindings. And how are you doing VSCs in Rust?
Yeah, you mean how this entry point looks? Do you want to see some
No,
example?
I'm asking about you're probably using some existing libraries and tools to do the
Oh yeah,
VSC part of things, right?
yes. There's some other developers. They created some bindings, some VST bindings. It's called VSTRS. Let's have a look at that. And this allows you to access a large part of the VST2 API.
Yeah, so last time I checked this, it was saying VST2 and it's still saying just VST2. So people who are getting into developing VSTs cannot do VST2s because of licensing. So how do you deal with that? Do you have a license from old times, or do you do VST3 in some other way?
Well, this VSTRS, as I understand it, it doesn't use these VST header files, and it also it more uses these magic. I mean, we could have a look into the source code. I think API or plugin. I'm not sure where, but it uses these very low level API of that happens to be like the VST API. But
So they're sidestepping the licensing issues.
yeah, I guess if not, then you can always use another plugin standard. Like so you could also use LV2 or things. It's actually not that important that it's VST.
I see. Okay.
Like the main thing is with relearn, for example, is that you get access to the media stream and to the audio stream and some more things, but that's about it. And this is something that every plugin standard provides.
All right. Okay. So tell us about the events and how to listen to events in your extensions, something that you cannot really do in Lua. As far as I understand, if you're interested in events in Lua, you have to just query in a loop.
Yeah, that's also what I think. But I don't do much Rescript development. So I'm not sure. But I can show you how to use it, how to do it in an extension. So there is this. This is now the REAPER SDK, REAPER plugin header. And there you have this virtual base class, which it's called iReaper control surface. And these are callbacks. You can just implement them. So you can be informed when, for example, a track volume is changed and so on. And this thing you can register in Reaper. It doesn't even need to be a control surface that pops up in this control surface section in the preferences. It can also be a hidden, like Cocos calls it, control surface behind the scenes. It doesn't occur anywhere. It's just in memory, and it's one way to get called back about some events that occur in Reaper. And I made that quite easy in Reaper IS. So that's at first. I'm not sure. Did you hear about traits in Rust? It's a little bit like.
Yeah, I know about them, but I think we should explain them very briefly.
Yeah, well, it's comparable to a completely. Well, it's not the same, but it's comparable to an interface in Java, for example. But you or a virtual abstract base class, which is completely virtual, like a little bit like that in C++. I think you will get an idea of it when I start coding. So I will just define a struct, which is now my control surface, and I will say, okay, this is a control surface trait. It's like a collection of things, like a contract. It's a contract, and I implement this contract for my struct. And now I can.
When you say contract, you mean just signatures, right?
Yes.
Okay.
Just conceptually, it's like a contract.
Okay.
Yeah.
Because contracts is a loaded term. It means other things to other people. Like, I think that in C++ there will be a concept of contracts that is runtime verification of invariants. And that's how it's understood in, for instance, the scheme community. A contract is something that verifies at runtime. And this is just function signatures. It's not doing any work at runtime.
Yeah, then let's not use this term contract. No,
it's a fair term. It's just that different people can understand things in different ways. That's why I'm asking.
Yeah, it's good that you check. Yeah, it's signatures, function signatures, and so control surfaces need to be debuggable. Like, I'm not going to explain that now. It's not so important. And then I can implement some of these methods.
That's very cute that it shows all the methods you could implement.
Yeah, that's a typical JetBrains feature.
Yeah. And by the way, I guess this is a good time to ask a question Bo asked here on the chat. What's the upside of CLion as opposed to other IDEs? I know that you're using it because of your Java heritage, but what are some things that you like about CLion as opposed to, I think that many people are using Visual Studio Code for Rust, and I suppose that other people are, I don't know, using other things. Like, for instance, for C++, people would use Xcode. So what is it about CLion that you like?
Well, I like that I'm used to it. That's really a big thing. Like, if I'm fast in this IDE because I know all the shortcuts, and if I would be used to Visual Studio Code or to VI, then I would use that one because I'm used to it. So I'm not sure. Like, of course, I like all the features that they have, but I think it's mostly a question of what you are used to.
Fair. Yeah. And it's nice that using the same ecosystem, the same buttons are in the same places, and the keyboard shortcuts are the same. And it is cross-platform and it is cross-language. So if you're doing C and I guess Rust, you can go to CLion. If you're doing web things, you go to WebStorm. If you're doing Java, you go to the Java one whose name I forget. But it's all the same.
Yes, that's exactly the point. Yeah. Because I do a lot of programming in other languages too, and then I want to have the same experience, and it's a huge productivity boost.
Yeah. All right. Yeah. Okay. So continuing, moving forward, you're implementing this function that will be called when volume changes on a track. What are we looking at here? When the volume changes on an item, on a track?
On a track.
Okay.
It's when a track volume changes, and even more frequently than necessary, but you will see. I will just push out a message like that, and then I have to register this. Like, of course, I somehow need to tell Reaper that this is a control surface and please call it. It's always a bit weird that it's named control surface because there's no actual hardware behind it, but that's how it is.
I find it very weird that it's under control surface. I can see I don't know the history there, but I can imagine that it was like, oh, we need this API for control surfaces. Okay, we'll call it the control surface API. Oh, it actually is useful in other contexts. We'll continue calling it the control surface API. And also, we'll not call it control surface, we'll call it CSurf. Because then people can imagine what that stands for 1 month or two.
Yeah, but that's okay. I didn't change that naming because it's medium level API and I want to stick to the original.
But I really appreciate line 18. Line 18 is lovely because it says control surface instead of CSurf.
Yes, I don't like the abbreviations so much, so I just mostly use the complete word.
I agree. I am known for long variable names, and to the point where it gets verbose and noisy at points, and then I have to dial back. But I prefer to have verbose and then clean things up than to be too concise, and then people will not understand what I mean. Anyway, so we are now registering the my control surface struct as a, I guess, observer, right? It will be receiving events from Reaper.
Yes, that's it. So I'm just do it a little bit differently here. Like as soon as we want to register something, we need to use this some construct of the medium level API. It's called medium session because the medium level API takes care of keeping certain things in memory. For example, this control surface instance. It's not just, you cannot just call a function and everything is fine. You need to this control surface needs to stay somewhere. It needs to live somewhere in memory. It's not enough if it lives during the execution time of this function and then it's gone, because we want to be called back. It needs to be.
So this is the median session thing is the person in the middle who is managing all the listeners and receiving the events and dispatching them, right?
It's close, yes, close. Mainly, it's keeping objects in memory that need to live there, like so that you don't have to make them static.
Okay.
So basically,
the median session is going to make them static for you, right?
No, not that. It's more like you have one thing that's static, and it's one thing is just one struct. It's this high-level Reaper struct. This is available in a static variable, and from there you can reach everything. The other things are not static. That's the idea.
Okay.
So I wanted to have a not much static state. So here we can access the medium session. It's a member of this, and here we can also use the typical function names. Plugin register is the let's see, plugin functions. This is the original API, and there we have plugin register. This is where you register all kinds of stuff. You register control surfaces, hidden control surfaces, you actions. This is a very important entry point for registering stuff in Reaper. And you see the signature, a name, and this can be anything.
A magic variable.
So, yeah, it can be anything. And of course, I wanted to make it more Rust-like, so I said, okay, I call this plugin register, but I do provide some suffixes which are actually type safe.
Nice.
So I have to just put in this my control surface now, and that should be it. So now I register an instance of this struct. There's only one. And let's
Before you build, don't we want a new line in line 20?
Oh, it's so good that you remind me. yesterday I was trying this a little bit, and I always forgot the new line. Like it was, and today turns out I also forget it. But you are here, so thank you. So we compiled it, and let's start it. See, there's already some callbacks. Even nothing happened yet, so that's so.
Perhaps the master track. It's alerting you about the master track volume.
Yeah, it's probably the master track, but it's yeah. So I think originally this API was used for pushing changes out to control surfaces, and yeah, it's actually okay in many cases if you are informed not just once but also more
which is already better than what we can do in Lua. As far as I know, the only thing we can do, we cannot register listeners like this. The only thing we can do is have a defer function that will be called in a loop. And then we have to keep track of volumes that we know of, and we have to ask about the volumes on the tracks, and then we have to see if the volumes have changed, and then we do something. So it is that running in a loop over and over multiple times a second, while this is only being called, what, 12 times?
Yes. I'm not sure if this is a big performance difference, maybe not, because, you know, a desktop application like this, it runs in a loop anyway. Like everything you see here, it happens in a loop, this main loop. So probably Reaper, I guess, does something very similar, like always checking, and I'm not sure. But anyway, so I'm not sure if it's a performance advantage, but it's for sure nice to have some callbacks. And now I show you here. We see we get called back whenever something changes on the at some volume. And when I, for example, mute or solo the track, we are not notified. Or we are notified, but I don't do anything.
And if there is some volume automation on a track, when the playhead goes by, you will be called a bunch of times.
Yeah. Constantly. I will be called back constantly, I think. And then we can, of course, also, I mean, we are called with some arguments which you can print out. So yeah, this is the arguments. I will just print them.
Is the exclamation mark because this is like a macro or something?
I mean, this question sign?
No. The exclamation mark. It's format bang.
Yeah. Yeah, exactly. It's a macro.
Okay. It even highlights differently. I get it.
Yes. This is a very famous macro in Rust. People use it quite often. Yeah, and now we get called with a track pointer, and also we can see the volume value that actually is invoked.
Nice.
It's obviously not decibel. It's something else. And I called it Reaper volume value. So because there are different ways in Reaper to represent volume. So having these new types, these wrappers, is a nice thing to actually know what kind of volume value it is. Is it decibel? Is it this? Is it a normalized value that can only go from 0 to 1?
And in that case, it's not a type-only thing. This is a runtime abstraction. The Reaper volume value is something that is kept around for, well, values, right?
No, it's the reason why we see this Reaper volume value, this name here, is because let's go here. let's go into Reaper as. It's good style in Rust if you write an API for other people to implement certain traits. And the trait we are seeing right now is a debug trait. And this debug trait does nothing more than taking this the name of this struct and then say, okay, if you want to debug me, if you want to want a debug string of me, then just print this. But internally, it's still a primitive double, nothing more at runtime.
Oh, that macro had access to the type.
No. It didn't have access to the type.
Well, someone has to have access to this type. If it's not attached to the value at runtime, if there is no flag attached to the value at runtime, the macro has to have access, right?
Yeah, but you're right. The macro has access to the type because it runs during the compilation process very early. But it's not the reason why we see a Reaper volume value printed on the screen. This is because we derive an implementation of debug. I could also just take it out, and I could say impl debug for Reaper volume value, and then I could do this.
Yeah, but I guess what I'm trying to say is that this debug trait is informing the format macro.
Well, the format the macro uses this method.
I see.
It uses this method. Usually, it uses a toString, or it uses the another method. But because we have this question sign here, it uses a debug implementation.
I see.
So,
okay.
Yeah, that's the reason. So it's a bit misleading. We don't have this wrapper type in the memory. We only have this number in memory. Yes.
Hang on, now I'm thinking about this. There must be some way for the compiler to dispatch to the right formatting function. So it needs to keep around at runtime. If it's not going to do this at compile time, I think it's going to do it at compile time because the abstraction really seems to be free. Anyway, I think that's a minor point.
Yeah, of course, the function is compiled like this. This will be available at runtime, this function, but there will not be this will use just these.
Yeah, it's not only the function that needs to be available at runtime, it's the dispatch table that needs to be available at runtime because you need to know which function to call. There could be multiple implementations of format for different kinds of numbers, from BPM to Reaper volume value and so on. They will have different implementations of format. So you need to know which one to call.
Yeah, but it's not like in C++ where you have this V table, this virtual table, and then you look at runtime which function actually needs to be called, because in Rust you don't have a class hierarchy. You don't have that in Rust.
Okay.
So
is there the concept of classes or just structs?
Just structs, and you also don't have polymorphism.
Okay.
So Rust is a kind of object-oriented in one way, but it's a totally different kind of object orientation than C++. It's more like a contract basis. No, I'm using that word again. Like an interface-based object orientation. It doesn't use. You don't have these super deep class hierarchies in Rust. You cannot have it. But it's a good thing.
I like that.
Yeah.
I'm not a big fan. I don't know. Maybe because you are you have experience using Java, you may be comfortable navigating this, but I am always like, what the hell is going on? I am in the middle of a tree that has 1,000 classes. What do I do?
I have the same opinion. I don't like it. like these hierarchies.
Okay. I have another
So
question for you.
sure.
Where does it break down? What are some things that you just showed us that there are some things you cannot do in Lua, or that would be trickier to do in Lua? And there you mentioned before how there are some things that just plain cannot do, like intercept the audio and MIDI as part of a plugin chain. There is no way for you to create a Lua VST, so to speak. And then you showed us how it's possible in Rust. But what are some things that it's not possible to do? You cannot do them in the Reaper API at all, not even in C++ or Rust or anything.
Oh, probably there are very many things you cannot do.
Have you ever wanted to do something and you were just like, impossible, I have to ask the developers?
Yes, yeah. Fortunately, I don't hit the limitations often. I'm really impressed by how comprehensive the Reaper API is, but sometimes I would like something. For example, for playtime, I would like that the MIDI editor can be used more, more like a module, and that you actually don't need to have an item on the screen. And at the moment, it only works if you also have an item on the screen. Things like that. Sometimes I miss functions, but fortunately, it doesn't happen so often.
I see. So is that one reason why you would want to have a separate application that talks to Reaper via some inter-process communication thing?
You mean why I chose that way for?
No, I'm saying that there are some things you cannot do in Reaper, and then you said before that you were planning on having a separate application that talks to Reaper, that controls Reaper. So is that what you just explained, these limitations of the API, the reason why you would want to have a separate app?
It's not to compensate what I cannot do with the Reaper API. It's not that. If I want to somehow do something in Reaper and Cocos doesn't provide any extension point for it, then there's nothing I can do. I cannot. Then it also doesn't help if I have some external application talking to Reaper. Within Reaper, I can. If I use Rust, if I use a native language, I can do everything. I don't need an external application. For example, relearn, it boots up a HTTP server, a WebSocket server. I can do all of that. I could even, I don't know, I could do a lot of crazy stuff. Like it's like writing a standalone software. Because you're not sandboxed. You're running at the same level like Reaper itself.
I see.
So the only problem is that the Reaper API sometimes doesn't provide extension points, so I cannot change certain things in Reaper itself. But other than that, I can. It's possible. You can do everything.
Interesting. Nice. Okay, and another question I have is, what was the migration like from C++ to Rust? Besides the work of creating the bindings and everything, the work of taking the old code base and sort of translating, but also changing it along the way. So what was that like?
Yeah, I tried to stay very close to it. So because if you try to port something and at the same time change a lot, then this doesn't work out so well. It's too many things doing at the same time, too many things that can go wrong. So at first I tried to stay very close to my original code.
The second system syndrome, right?
I don't even know what that is, but
You don't? The second system syndrome is when a team decides that they need to either port to a different language or that they need to rewrite to use different tools or a different architecture. But then they decide that the second system is also going to be better in some way. So they introduce changes along the migration and it never comes out.
exactly. That is what I wanted to avoid. So I stayed very close to it, and then later okay, some things have to be done differently. For one, I can give one example. It's in the C++ world. I used reactive extensions. I used Rx a lot. Like I was used to it from Java, from TypeScript, and so on. So I used them a lot. There is a thing called RxCpp, and so I was thinking I also needed in Rust. So I was looking for a reactive extensions library in Rust, and also used it. Also contributed a little bit because it's not as mature than the C++ version. But later I discovered that in Rust you write things a little bit differently, and I removed some of my usages of the reactive extensions, and I prefer to do it more straightforward.
Yeah, I not personally not a big fan of this style of reactive extension. I find them more trouble than they are worth in most situations. So I'm happy that you also made this decision.
Yeah, it's still at some points it's still there in relearn, but it's only on the user interface layer. So I have it divided into different layers, and the processing layer, which you can use independently of the user interface layer, it doesn't contain, at least I think, it doesn't contain any reactive extensions anymore. Yeah, but sometimes it's just better to that you write more understandable code where you immediately see what happens, like not have the control flow hidden in a lot of operators. Yeah, sometimes that's better. And I found for this processing domain, processing media messages, and for sure processing audio, there I never used it. It's better to have more straightforward code.
Yeah, that's my preference too. I feel like you had more things to show in this code base, right?
If we still have time.
Of course.
Yeah, then I will go ahead. I wanted to show, let me think, registering actions. You can actually, if you are an extension, you can, or a VST plugin, you can dynamically register actions.
And this is something that you have to do every time you start, or is something that you do once and then Reaper remembers that your action exists and remembers how to call it?
No, you have to do it every time. And that can be considered an advantage, depending on what you want to do. So I will just quickly show how to register an action, and then we can move on from there and explore other stuff. So at first I will hide this message. And now we are going to register the action. Let me think. So as soon as we want to register something, then we need to go into this session. Oh, but actually I didn't want, I wanted to show the high-level API at this point, because I told you the medium-level API, there's only so much you can do to make it convenient. And in this case, registering action is not very convenient if you just stick to these functions. It's done by calling plugin register with a so-called hook command. And I wrote some documentation how to do that, but the way it works in Reaper is that you have a command ID, which you at first need to acquire from Reaper. Then Reaper gives you that command ID, and then you get called back whenever an action is invoked, and you have to check for yourself, is it your command ID? So
Huge.
that's the way. And but it probably has some benefits. It allows you to do stuff that you would not be able to do otherwise, maybe. But I want a very straightforward API. I want to just do register action, and then I pass a command name. Let's say hello world. Then some description. This is a thing that will appear in the action window, and then we have the actual function, which the code which gets executed when we execute the action. And I will just do this show console message hello.
Is this pipe the syntax for lambdas?
Yes.
Cute. And that is probably a list of arguments, right? In this case, no arguments are passed, but if you had an argument, it would be passed between the pipes.
Yes.
Okay. This is very Ruby-like.
Yeah. It also reminds me of Ruby. I'm not sure now. C++. It's so long ago. I'm not sure if they also use the pipes.
No. In C++, it's square brackets.
Right. That's it.
Well, it is both square brackets and parentheses. The square brackets to capture environment variables.
Mm-hmm.
I shouldn't say environment variables. That's a loaded term too. It's just variables available in the context of the function definition, and then parentheses for regular arguments to the function. So the arguments that the caller will pass, not the place where the function was defined.
Yes, I get it. So this is a high-level function, and I'm not satisfied with the signature. It will probably, I will change it at some point. So don't use it, but that should just work.
What do you not like about this? It seems very clean to me.
Yeah, it's first world problems. It's just I don't know if this is the ID or which parameter is the ID, which parameter is a description. But it's not that important now. Okay, or do you want to go into detail?
No, I just wanted to know, because if this looks very clean to me, but you are not 100% happy with that, and I wanted to know why. So it is just that you could swap the two strings if you don't know what you're doing or something like that, right?
For example, like somehow if you program Rust and you see these libraries existing, then you see, they make really APIs that you can use very nicely and has a lot of type safety. So automatically you also want to do that.
Could you just have named arguments for the two first arguments? Because that would clean things up. You would say something like ID equals hello world.
I think if I miss something from Rust, then it's named arguments and default arguments.
Okay.
Sometimes you can quickly get around it by using structs, but yeah, let's see. It's not that I need them, but sometimes I wish they would Rust would have them. So let's see. One thing that I tried it yesterday and it didn't work, and I forgot one line. I have to wake up Reaper. This is some concept I did in the high-level API, so that this works, register action, and then it will just register the action and you will be called back. You need to write some setup code, and wake up takes care of that. And you can also put it back to sleep. Then it unregisters the things, this is, for example, very important if I use a VST plugin. As soon as I unload the last instance, I need to go to sleep again, because I want that no traces are left in memory.
I see. Weird names. Wake up, go to sleep.
Yeah, I could also. I sometimes like these everyday live names. I could maybe activate and deactivate would be a little bit better.
Yeah.
But so what?
Okay, before we build, can you put the new line on line 20?
Oh, thank you.
And can you put it after the exclamation mark?
Oh, no. You're so picky. Okay. Thank you. Let's see if we get our action. Oh, I still have this hello from Reaper. Okay. I say hello world. It's there. It has these command ID, always with a underscore in front of it. This Reaper does that. Yeah, and then we just get our hello worlds. So this is how you register actions. But what I actually wanted to show you how you can then implement that action. Maybe we can just. I want to show you how to work with iterators. So let's say this is a function. Show f. Maybe we can show all effect instances. So I will replace that with this function. So it should just call this function whenever the action is invoked. Then I say, okay, Reaper, give me the current project. Then give me all tracks. And I can just iterate over them. Like tracks doesn't return a vector or a list. It iterates. So if I stop iterating early, it doesn't have to go over all tracks. So and then let's see, we can just go to the fx chain, the normal one, not the input fx chain, and get all effects. So now we already have access to effects. So let's now simply show the name of that fx. I just migrated to Mac OS recently, so sometimes I don't find the keys. So
You used to be working on Windows or Linux?
Yeah, somehow I worked for a long time on Windows.
Okay.
And now I have the problem when I go back to Windows, then I don't know the shortcuts there anymore.
What made you switch?
I like the MacBooks, the new MacBooks. I like them, so that's why I switched.
Fair. You could be running Windows on them.
Can I? Yeah, no, it's okay. Thanks.
Well, now that I think that Windows 11 has ARM support, but I don't know if it has everything that is necessary to work on the M1 processors. I would expect so. It stands to reason that Microsoft would do that because for the longest time, one of the best machines to run Windows was Macs, before, of course, the Microsoft Surface and all the computers that they do. But I don't know. Maybe it's not possible to run Windows on the M1 processor.
I never investigated it now. I just want these things to work at the moment, and so far it works quite nicely.
Yeah. I'm finding that more and more the operating systems they don't matter too much.
Yes. I always like a cross-platform software. If one software is not cross-platform, I tend not to use it. So I want to be able to use the same tool, if somehow possible, on all platforms.
Yeah.
Okay, let's see if the action works. So let's create some tracks and some don't know. Whatever's
I
in
forgot to
Reaper.
double check your new lines before you compiled. I don't know if you have the new lines now.
Probably I missed them.
We'll see.
Yes. So yeah, well, we don't need much. So just to yeah, I didn't I didn't put a new line, but you see it's it prints out the all fx names. It works, and the nice things, these are iterators, so you can just, for example, if you want a vector of all effects in your project, then you just use oh, sorry, I'm a bit too high, like too low. So and now I can use these typical functions which I missed so much, like flat map, and then I can from there I can get all fx on the fx chain, and at the end I should have a vector full of effects, of all effects in the project, at least the ones which are on the tracks. So and things like this are very useful if you work a lot with the Reaper API.
Yeah, these 4 lines that you wrote would be more like, I want to say 15 lines of Lua if you were to use just the low-level API.
Yeah. Oh no, Rust complains. See that this is some things you need to take care. Like maybe it's better if I don't. Wait a moment. Let's see what Rust says.
I am in front of the error message. Returns a reference to data owned by current something.
Yeah, fx is self-contained, so it wants you something that could break. That, for example, a reference is not around anymore, and it would crash. Let's see what is wrong here. Like this, the problem is that we have an iterator, and iterator keep iterating as long as they have access to self, like here, because this iterator depends on self. So probably, yeah, Rust is definitely right. There's something is off here. I would just make it easy for me now, and I would just make sure that that I have wait.
Yeah, that's what I was thinking about. The effects function is going to return an iterator. So if you realize the list, if you turn the iterator into a list or a vector, you should be able to just get by, right?
Yes, you can do that. Now I don't know. I have a blackout. I don't know. I would need to have a look into it. How to solve that is probably something very simple. But yeah, I can send you that example later. I don't want this to stop now.
Fair.
What I still want to show you.
But this is what you did, right? When you say .collect, you are saying turn this iterator into a vector.
That's true. But I wanted to do it at the end, like not here. So at the very end, when I have a iterator of everything, then I wanted to create then I wanted to create a vector, but not for each track. That's the point.
I see. Yeah. Okay. But yeah, let's go with the .collect there, just so things work.
Yeah, that would not work because it would work, but I have to write a little bit more so that works. So that probably should do it.
What's the difference?
It needs to know into which data structure to collect it. Like collect you can use also for hash maps for a lot of structures. Like it's very open. So I need to tell it to which structure to collect.
And the only way to do that is by assigning to a variable. Couldn't you do something like in Java, you would probably put it in the brackets?
Yes, this is called turbofish in Rust. There is an operator that is, looks funny. It's not so common to do that, but it could be done.
Okay.
But I always get it a little bit wrong because the syntax is a little bit strange. That's why usually turbofish is not used so much. But yes, that's it. This is a turbofish.
Cool.
It looks a bit like a fish.
I can see why.
Yeah, and now we just circumvented this lifetime issue, but I just did something wrong. There is also a way to do this without collecting into a vector for every track. So let's say hello, but at first we insert some tracks. Let's do some cover stuff. Yes, and well, this is a debug output, which is not pretty printed, so it looks a bit like chaotic.
But speaking of pretty printing, I see that when you save or when you build, I don't know, it is auto-formatting the code. Is this something that is like in Go, where it is very strict, and if you don't follow the convention, your code doesn't compile? Or is it more like in JavaScript, where there is a bunch of tools that do this?
I love how it's done in Rust, and it's not like Python that you have to keep a certain formatting. You are pretty free, like in C++ or Java, but there is one tool called Rust Format, and it's the de facto standard tool, and it also comes if you download Rust, if you install Rust, you get it automatically, and so most people, I think, who use Rust just use Rust format, and it don't even configure it. Like they just say, okay, I run this Rust format always, like whenever you press save or whenever you commit, and then you can be sure it will be formatted nicely, and you never have to you have merge conflicts because of different formattings. I love that. This is one reason why I love Rust, because it has these tools, like tools, also a linter, which everybody uses, which is so good, which gives so good recommendations. And because everybody uses it, you don't have a very fragmented ecosystem.
I like
that.
Maybe
that's because Rust is relatively new. Maybe it will get worse, but I don't think so, because these tools, I never missed anything from them so far.
Nice. Yeah. Another part of the infrastructure that I want to talk about is something that is probably going to be exciting for you, and that's testing. You have a great story to tell about testing, right?
Yes. Should I jump to that?
Yeah. I mean, unless you want to explore other things here.
Well, yeah, depends on you. I still had the idea to show an audio hook. This is something you can...
Okay. Let's do that. And Bo has some insight here on Windows on Mac is weird. Keyboard commands don't work or don't sync. all sorts of weird things happen. So that's that.
Oh yeah, I can sing a song about that. That's right. It's here, for example, I couldn't help, but I'm actually using a key mapping here, which is like the one on Windows. I cheated, yeah, but yeah, the X win, because I'm much more used to this, and as I said, it's that's a big part why you are slow or fast, like the key bindings.
I find that I'm relatively okay with adapting to key bindings in different platforms, and like the keyboard in macOS uses Command, which is right next to the spacebar, while on Windows we tend to use Control, which is to the left. I'm okay with that. What I'm not okay with is when simply there isn't a way of typing something. Like for instance, on Windows, there is no easy way for you to do proper quotes. And by proper quotes, I mean curly quotes as opposed to straight quotes. In macOS, you can hold Option and use the square brackets for that. On Windows, it's just not possible. So I have to use, what is it called? Alto something something.
I didn't even discover this curly quotes yet, because I don't know them from Windows.
Yeah, they don't exist on Windows. I guess you have to hold Alt and then type a combination of numbers, which is just ridiculous. But Alto Hotkey, I think, is the name of the thing. And then I can use that as a keyboard mapper. So I can have my curly quotes, my M dashes, and all those other characters that I like to type.
Yeah, Auto Hotkey. Sometimes it's a tool that helps really much. Okay, let's see how to implement an audio hook. Like my goal now is to be called back in the real-time thread, like in the audio interface thread, and to capture MIDI messages from connected devices. Okay,
so we are not talking about tracks and effects on tracks. We are talking about Reaper is going to receive audio and MIDI. Before it routes the audio and MIDI into the tracks, we are going to intercept and process.
Yes, we can intercept it before or after. And we will see how it works. Of course, you can also do this in a C++ an extension, but I think you cannot do it in ReScript. So let's. It's the same principle like the control surface.
I guess it goes without saying that anything you can do in C++, you can do in Rust and vice versa. It's just a matter of how the code is going to end up looking, right?
Yes. Well, it depends a little bit. Like you can produce any result, but for example, certain features, for example, if you want to talk to C++ virtual base classes, this is not supported. There is no way to call from Rust into like some virtual functions. This you cannot. So you need to, because the ABI, the binary interface of C++ is not implemented in Rust. So you need to take the detour, or at least this is what I did whenever I want to call a virtual function. I take a detour and I need some C clue code, a C++ clue code.
I see.
Yeah.
Okay.
But fortunately, the Reaper API almost only consists of C functions. Like there are not so many virtual like base classes.
So I guess one could argue that this glue code is part of the bindings. It's not a simple FFI, but it's part of the bindings. And then my argument stands. Anything you can do in C++, you can do in Rust, and vice versa. It's a matter of how the code is going to end up looking.
Yes. You as a consumer of ReaperOS, you don't need to bother. Like it just works. But exactly. So you don't need to write C clue code make
Nice.
it work.
I noticed that in some situations, the callback function was a struct that implements a trait and blah, blah, blah. And in other cases, it was a lambda. What is the thought process? Why would you use a lambda versus a struct and vice versa?
Well, this audio hook stuff, it's the medium level API, and these things I'm going to show you, and this control surface thing, it's part of Reaper Medium.
Ah, I see.
So I wanted to keep it close to the original, and Reaper API doesn't use any lambdas, so which I'm quite happy about, because that would be hard to translate to Rust, harder than just this.
Oh, really? Interesting. Okay. Because
Yeah.
there is the concept of lambdas in C++ and also in Rust, so I
Yes,
would imagine that it would be relatively straightforward.
Well, maybe they are. I didn't look into it recently. Maybe they are. I think they are coming up libraries, crates for Rust, which make it a little bit easier to interface with C++ and also the advanced stuff. But the last time I looked into it, I found that it's best to just write some clue code for the C++ features.
Okay. Well, when we were talking to Justin, he said that he writes C++ like 2005. So we don't expect to see lambdas in the APIs anytime soon.
Yeah, and if he does, then it's also not a problem. Then you have to write a little bit more C++ clue code.
And I guess that would be not something that you could automate, like you automated the creation of the rest of the API.
Maybe you can, but it's probably a bit more effort.
Fair enough.
Yeah. Okay, so let's see. I have this on audio buffer. Similar to control surface, I have an on audio buffer trait that I implement for my audio hook. And yeah, we will be called by Reaper in this method. And yeah, so this is called very often, depending on your,
I guess once per buffer, right? So depending on your buffer size in Reaper, this will be called more often or less often.
Yeah, actually 2 times per block, like because there is an isPost. One time isPost is false, and I think that just indicates that it's before it keeps routing the audio and MIDI stuff to the tracks, and then the second time isPost is false. It's true. It's true.
I see. So this is like audio is coming in from the audio interface. It is passed through this audio buffer function we are implementing. Then it goes through the routes and through the tracks and effects and sliders. I mean, volume sliders and panning knobs and all of those things. And then it would go out again. So I guess it's more like the monitoring effects. And then your method is called again at that stage, so you can do some post-processing. Is that right?
I guess. I'm not 100% sure about the signal flow, but something like that. So maybe, I'm not 100% sure. So far, I'm only reacting if isPost is false, like. Because relearn, it can act as a global MIDI filter. And so I capture the MIDI messages here, and then I just, the ones that I use in relearn, I optionally just remove them. So they don't even arrive at the tracks.
Okay.
This is one.
So I guess one can think of this as a global VST.
Yes, it's a global VST. So there's one problem here, but yeah, you will see. At first, let's register this hook.
I think it's medium session, not medium Reaper, right?
You're absolutely right. It's a medium session. audio register hardware hook. And there again we create a box, which is a little bit similar to unique pointer in C++. So we want to create this my audio hook on the heap. So we register it, and now we want to see are we called back correctly. And because I don't want to print, well, we are called very frequently. I don't want to print every time, so I make a little counter here, and oops. I make a default version of this struct where counter starts with null. And then I just going to increment it, and then if self counter like every 100 time maybe, then I do something. And at first I will just print something onto the terminal. I will not, for a good reason, I will not print it out to the console in the Reaper user interface.
Okay.
Yeah. So, let's see what it does. On that occasion, I will also remove this annoying hello from Reaper. Oh, of course, I forgot to actually create an instance, the default instance of my audio hook. Because now I have members, so that it's not a singleton anymore.
Okay.
And let's see what happens. Yeah, so we are called every 100th time. We print this message, and the reason why I didn't use Reaper, I can try it. I will just show you what it says. Show console message. It's also in the part of the high-level API.
Oh no, don't do that. First of all, we need a new line, but also, please, on the high-level API, make a print line version where you don't have to remember the new lines, and don't call it show console MSG.
Yeah, whatever.
Please.
Yeah, you can do that. You can build your own high-level.
Please
API.
just call it print, call it whatever. Show console MSG. No.
Yeah. There's a reason why you should not use the high-level API. So. Okay, and we got a big panic. And actually, that panic, this is something I want to improve. It comes again and again. So,
cute.
But the same is also logged on the terminal. Called main thread only function from wrong thread.
Okay.
Yeah. When this code is executed, we are in a real-time thread, and most of Reaper's functions, they are supposed to be only called in the main thread. So, and this is something you really need to take care of when you develop extensions. If you're not in the main thread, most functions don't call them. Sometimes it works, sometimes it crashes.
Okay, I remember seeing, when we were diving into the implementation of the bindings, I remember seeing something like, this can only be used in the scope of the main thread or something like that. So it stands to reason that you would be able to catch this at compile time. And yet you didn't. So what happened?
Like Rust itself doesn't provide any means. If as soon as you leave Rust's, as soon as you have a foreign language interface, Rust cannot really help you with thread safety anymore. It can help you as long as you stay in the safe Rust world. It helps very, well with that, but as soon as you use communicate with a C++ or a C application, it cannot. But I tried to introduce a little bit of compile time safety by using traits. But this is in the Medium API. For example, in the Medium API, I can acquire an instance of REAPER, which has a real-time thread scope. And if I have this real-time instance, then I can only at compile time I can only call the functions which I marked for real-time usage. And if I create the normal REAPER like this, then I can only call the main thread stuff. But when I use a high-level API, I couldn't. It's just a little help, you know. In the high-level API, I didn't make this distinction anymore, and I'm just trying the best to prevent a crash at runtime. And this is what I did. Like usually it would crash, but show console message. Actually, I'm also doing this in the REAPER in the medium level API. I first check, are we really in the main thread? It's a very cheap check. Doesn't really add any significant overhead. But it's very helpful because if you make a mistake, and programmers make mistakes, then at least you don't lose your project because REAPER crashes.
I see. I thought that line 481 would be some kind of static check.
That's a static check, yes.
Okay.
But it can only help so much. Like it's also pretty unusual. Let's say I think I've never seen any library which does that. But I just tried that to make it a little bit more safe to use at compile time already.
But it doesn't work when we are doing the thing that we are doing in our little project, because we are diving into the C++ interface, right? When we are on that structure and implementing that trait, you don't have access to where that trait will be, in which thread that trait will be running. Is that the issue?
Yeah, the type system doesn't have any idea about in which thread we are running as soon as you use FFI.
I see. Interesting. Well, at least there is the runtime check. Hey.
Yeah, so I thought a runtime check is better than nothing, better than crashing. So that's what I added.
Okay. So we know that we are on the audio thread. Can we do some audio processing there?
We can do audio processing. We can capture MIDI messages and so on. Maybe I show you that first, but of course there's also a solution. If you really for example, want to print a message whenever a MIDI message arrives, then what you need to do is like sending this message or sending some kind of value to the main thread. And then,
so I thought, it would be inter-thread communication, sending a message to, please run this function that I cannot run.
Yes, that's one way of doing it. Of course, you also can work with mutexes, but I really like this communication via channels or queues. It's pretty nice, and it also doesn't, in the audio thread, you should be very careful not to lock a mutex too long, or maybe not at all even. And so I prefer channels.
Yes.
But at first, let's see how we can access the incoming live MIDI messages from here. So there is one method in Medium REAPER. It's called. Actually, I want to use the high level stuff now. MIDI input devices. It's an iterator over all MIDI input devices, and I'm going to just iterate over them. And this has a method which allows me to safely access the MIDI stream.
Okay, so you're not receiving MIDI from Reaper, so to speak. You are sort of querying the interfaces or devices if they have anything for you.
That's the way you do it in Reaper. Yes, you just need to, and on the medium level API, you just have this get MIDI input, like it calls this get the input function. And this is audio thread only. You should not call it in any other thread. And here, for example, I don't do a check. I don't do a thread check because I was thinking, okay, we are in the read-time thread. I don't want to have any overhead. So even it's if it's not significant, I don't want to check that.
Yeah, I learned this the hard way. I was doing JS effects and I started building all this infrastructure, not unlike yours, that would do a lot more safety checks. And I was used to doing these kinds of things in other contexts and it would work fine. People would say, oh, it's too slow. And I would do it and it would be fine. But in audio processing, it's not fine. The overhead was like a deal breaker overhead.
Yes, yeah. You don't want to clicks, crackles, dropouts.
Yeah.
You don't want that. So it's possible that this MIDI device is not open. Here I do it with a closure, actually, a lambda. And sometimes you need to do these things to use such APIs to make it safe, like because so this is a safe API to access MIDI messages. Let's see how we can do it. The device is optional, and for optional things, Rust doesn't have null. It has option.
Yeah, there is now this in C++ as well, but I don't remember how they're calling it. Whatever.
Yeah. Okay. Wait. No.
It's not some and none. I think it's... I don't remember.
So let's just name it correctly. So we have the MIDI input. I check if it's actually available, the MIDI input, and not disconnected. In the medium level, this is all... Sorry. In the medium level, this is all documented. The high level API is not documented that much because it's not for the public so far. So now we have access to the MIDI input and we want to do something with it. Let's see what the input has. It has get read buff. This is also the original method name. So let's see what this gives to us. An iterator. It's an event list, MIDI event list, and this implements also. It's also an iterator. So we get an event. Let's see, a MIDI event. And this MIDI event can give us a MIDI message. So we could just print this MIDI message somewhere. I hope it implements debug. Let's see.
And right now you are doing this only every 100 blocks. But you could do this without that counter, right?
I want to do that without the counter. You're right. I don't want to miss any MIDI messages just because the counter is not a multiple.
That's what I was thinking.
So
because it's not the case that there is a queue of messages and you can tap into the queue whenever you want. You have access to that buffer that time, and then it's gone.
yes, that's it.
Okay.
Exactly. That's also why the only place where you should call that and is in this audio hook.
Fair. Okay.
So I have a keyboard here.
Nice.
A little now, and I press some keys, and it prints out the messages. You see, they arrive, and so it's to the frame offset.
Frame offset, then the 3 bytes of the MIDI message, right?
The frame, well, the frame of offset is actually what we are printing out is the event itself. That's a little bit misleading, and the event contains not just the message, it also contains the time, like within the block, which time within the block this event has.
And so your block size is greater than 10,000 samples?
No. The reason why you get this is not samples. You can read that in the depth of the REAPER documentation. Let's check. The frame offset is a MIDI frame offset, and you know I documented it. A MIDI frame offset is some fraction of a second. It's not a sample frame.
I see. So this frame offset is absolute in terms of since the project started? No, it's probably going to be relative to the block start.
As far as I know, it's always relative to the block start. Yes.
Okay. It's just counting time differently.
Yes.
Fair.
And this I like that you now have, you don't get just an integer, you get actually information that this is not what you think it is. It's it's something else. This is I personally find very helpful. So okay, I think we have 2 options now. I could show you this sending to the main thread thing, or this test thing. I don't know how much time we have left. What do you think?
It's up to you. I don't want you to have prepared something to show us and not have the time to show it. So
yeah, okay. Then I'm just going to show it, because I think as soon as you want to use write extensions and you want to capture MIDI messages and you don't just want to, you somehow want to communicate with the user interface, you're going to need something like that. So I will just show that. Similar to Go, Rust has the concept of channels. I already said that. And usually I use a third library, Crate, Crossbeam to do the channel thing. But Rust standard library also has channels, so I will just use them for a change. So we need a channel in the audio hook, and from this channel we want to send something to the main thread.
And so sending a message is something that doesn't block. It's completely safe to do in the audio thread, right?
We need to take care of that it doesn't block. Exactly. Okay. So you want to make sure that that it's like MPSC is the module which Rust provides. Multiple producer, single consumer, it's an abbreviation. And if we want it to not block, then it's important to use a channel that is bounded, that already has everything allocated right from the start. So
I see.
Because we don't.
But hang on. Multiple producer, we have in this case only one, right?
But it could be multiple.
Okay. But if if we wanted, is there a specialized type for single producer, single consumer?
Yeah, there are I think not in the standard library, but there are a lot of crates out there. For example, ring buffers, where you usually have only one producer. Yeah.
Right. Okay.
Which is also a bit more performant. Yeah, but of course you have to measure that. So we don't use this sender. We use I think. Yeah, so I'm not so super familiar with these built-in channels, but let me just quickly look. So this channel provides something it's called tri-send, and
you probably want to go with tri-send on the audio thread, right?
Yes, so that it doesn't block.
Yeah.
And I think the sync is then bounded. Sync channel. Oh yeah, here we have it. So the sync channel provides a bound. Like I can say, okay, I want to reserve, I want to allocate space in memory for, let's say, 100 messages. Okay. So it does this in the main thread. That's okay. We can allocate in the main thread. And what it gives us is a sender and a receiver. Sender and a receiver. And so we use this sync sender type here. I'm just going to import it, so I don't always have to write this MPSC in front of it.
So fix line 12.
Sorry?
Fix line 12. You don't need the on line 12, there is the MPSC, I guess, namespace. Is that how we would call it in Rust?
It's called module in Rust.
Okay, fair enough. But there you're saying MPSC, and you don't need to.
I'm trying to following a bit the Rust conventions, and the Rust conventions, I think they say, of course, use your mind to produce code that is understandable, but things like structs usually don't use so much these prefixes. But if you want a method and it's not self, you need a little bit more to understand the context, then you usually use this module name in front of it.
All right.
But you can do that as you want. Like, this is not a religion. So we need to think about what do we actually want to transfer to the other thread. In this case, I want to. I think it's a good idea to transfer the message, and for that, I'm going to add a new dependency because Rust doesn't really have transitive dependencies. So I need to explicitly add that. helgoboss MIDI is a little crate of mine which implements the MIDI standard and provides data types for dealing with MIDI.
You know what I think I would really like? I would really like to be able to send a lambda, because then I could, from the audio thread, I could say something like, run this on the main thread, here is a lambda. And then the code that you want to run is next to the code that is actually running the thing. The sender and the message are next to each other.
You can actually send a lambda, but you need to box it. You need to put it on the heap. And if you want to put something on the heap, you have to allocate heap memory.
And that can lock.
And that can block. So that's why I prefer not to send lambdas. I don't do that. Like if I'm somehow in a real-time thread.
Fair enough.
So, but yeah, I sometimes do that when I'm communicating. If I just want to defer some code, I'm in the main thread and I want to put it, send it, just execute the same code in the next main loop cycle, then I do that. So I sometimes send lambdas. You can do that.
Nice.
Okay, but now I send something that doesn't need any allocation. It's just that. So
U8
7,
is probably unsigned 8 bits, and U7 is unsigned 7 bits.
yes, this is not a built-in type. It's a type I created as part of this, this helgoboss MIDI crate. It just makes absolutely sure already at construction time that you have a number that is just 7-bit. Yeah, but you don't really need that. You could also use 3 U8s here.
Okay.
Yeah, but technically, a short MIDI message, like according to the standard, is only 7-bit, and so in
sure.
Rust, in Rust, typically people make everything very explicit. So
I like it.
So we have this short message, 3-byte message, and what we get from that. What we get from the event is actually just an implementation of a MIDI message. So we still need to get a raw short message from it. Event message. This is I made this like 2 other. So it just converts this message to another type.
Nice. And it infers which type to convert to by reading the left-hand side. Yes,
that's something very typical for Rust. Although it's actually more typical to do this into but I forgot why I used 2 other on this occasion. Maybe it was at the beginning of my Rust time. Or I think there was a reason. Maybe there's not. I don't know. So whatever, we have this short message now. It's important things that you send to other threads. They somehow need to be self-contained. It shouldn't be a reference to something, because references are they don't live long usually, except you have a static reference. Then that's also fine, but usually don't have static references. If you don't have something which you can easily make self-contained, then you have to use something like a shared pointer. And in this case, it must be a atomically reference counted pointer, because we are dealing with different threads. But for now, we only want to send 3 bytes. No problem.
We might as well just serialize that.
Yeah, it's totally okay to copy that. So we want to call the sender and say try send, and then put the message in. So so that it works, we have to create an object, like a value of this my audio hook struct, which
we can get rid of the counter. We're not using it anymore.
Good idea. Yeah, I always love to delete code. That code for. So we put the sender in here. That's it, and we pass this audio hook now. That is the one we created, which contains the sender. The example is not complete yet, of course, because we need the receiving side.
Yeah.
Okay. Yeah, of course, we cannot implement default anymore because there's no default for a sender. So if we do that now and we start it, it will just not do anything, because I'm now pressing my keys on the keyboard. Nothing happens because there's no one who actually gets these messages. So let's implement that part as well. And so we need actually something that continuously runs. Well, it depends. Depends on to which thread we want to send these messages. if we want to send it to a new thread, then it's very easy. We can just spawn a new thread, operating system thread, and then wait for these messages. We don't even need a loop. We don't need a busy running spin loop. Yeah. But because we want it specifically in the main thread, it always runs this event loop. We need to always poll. Reaper does that anyway, so we can just hook into it. So this control surface, this thing provides a run method. This run method is called around 30 or more times a second. And this is a perfect place where we can just get our messages. So Let's do that. We equip the control surface with a receiver.
So in this case, there is not even a new thread involved. It's just the main thread, and we will be running this function every time.
Yes.
Okay.
Well, Reaper runs it anyway, as long as we have registered this control surface. Reaper runs it just as it does many other things. It then, there's a control surface, then I will also run it. Okay. And by default, we don't do anything in here, so it's no op. But this time we want to do something. So we just do receiver. Self receiver, try receive. And now we can choose how do we want just one message in one main loop cycle, or do we want to query all messages? I will just use, I just get during one main loop iteration, I will just get all messages.
Yeah, exhaust the queue.
Yeah, I will exhaust the queue. So I get a message here, and I want to print that, and this time I can use that.
You know what would be really nice if we could detect in which thread we are running, which we already established is not possible because of the FFI. But if we could, instead of just checking if you are on the main thread and erroring and blah, 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 you could do all this message passing under the hood. Wouldn't that be nice?
Yes, yeah, you could do that, but I think that's not the responsibility of the medium level API, because it's too opinionated again. So
yeah, fair. Okay, I'm talking about very high level stuff.
Yes, but yeah, exactly. I would, and I also did something like that in the Reaper high level API. It has some function where I can just pass a closure to the main thread, or yeah. I have such a function, but yeah, it necessarily allocates, so I wouldn't use it from the audio thread. Yeah.
Right. Yeah, it's one of those magic things that come with a cost, but it's nice.
Yes.
Did you? I didn't check before you scrolled. Do you have the new line?
Of course not. It's a running gag today. So let's create the surface. I call it CSurf now.
Oh no!
And give it a receiver. So if I'm correct, that should be everything. Let's see if it works.
Hey, first try.
Yes.
Very nice.
Yeah, that's actually kind of a rewarding feeling when you do Rust. The compiler is sometimes so annoying, like so strict. But when it compiles, you can be pretty sure, not 100% sure, of course, but many things will work already. That's really nice. You feel more confident when it compiles than you do with C++, except you are a total crack in C++. Yeah. So yeah, that's what I wanted to show you before we can move on to this testing topic.
I also want to ask you about something else. I see on the right that you have GitHub Copilot. How are you liking it?
Oh, I have it disabled at the moment because I just wanted to give it a try. And I was, of course, fascinated about the recommendations, but I disabled it because, you know, I got code, like it's a recommended code to me, and suddenly I felt more like a reviewer, not like someone who codes. So I felt like reviewing other person's code, and that's why I disabled it, but it's still pretty impressive.
Yeah, same here. I have a stream. I actually did this on a live stream. I installed GitHub Copilot and I tried to use it. The feeling, I also disabled it after a couple of days. The feeling I had is that I had the code I wanted to write in my head, and I started writing it, and I was expecting Copilot to just fill in the blanks, but it was often enough suggesting something else that was sidetracking me. Like, yeah, you didn't really understand what I was going for, and you tried to suggest something wrong, which is even worse than not suggesting anything.
Yeah, that's the point.
Yeah, so when people talk about, oh, GitHub Copilot is a copyright infringement, and to some extent I agree, but the main point is that it's not even that good in the first place.
Yeah, I guess it has some value, but so far I didn't really use it.
Yeah. I guess if you are new to the language, and that's what I was testing as well, if you're new to the language and you're just trying to read the contents of a file or something so simple, perhaps GitHub Copilot can be faster than Googling and finding a Stack Overflow answer. But I don't know. I'm not a big fan, and I wanted to hear your thoughts. Okay, so integration testing. That is fascinating work that you're doing. So show us.
Yeah, so of course, as a developer, everyone tells you write tests, and of course, it's especially to avoid regressions. That's a very good thing. And when I was writing REAPER RS, I realized, okay, of course I can write unit tests, but the thing I'm writing here is mostly kind of adapter code, like. It doesn't really make sense to test it outside of REAPER. I need to execute the tests within REAPER and then check what it does, if it leads to the desired result, and so on. So and with relearn, I made something similar. Like I have a few integration tests for relearn, and maybe I can just execute them so you have an idea, and then I will show you how it's implemented a little bit. So I will just open relearn. Oh, wait, we have that here. And I have compiled it already a million times, so I don't need to do it again.
I remember back in the day, people used to complain about the compilation time of Rust programs. Is it still an issue?
It can become an issue, like if you, for example, if your software gets very large and you use a lot of generics, and you and you don't split it up into different crates, then sometimes it can become too much. But so what actually helps with that is splitting it up into different modules. This is one way. And yeah, the Rust team, they always improve on that. So it never bothered me. Sometimes I have to wait a bit, but I think the biggest point when you write code is actually thinking about how to write it. This is what takes time, and so I never really felt that that's a problem.
Okay, so separating in different crates is helpful because you can compile separately, and then
yes,
you will not be recompiling the whole thing.
Yes, because one crate is like in C++, one C++ file is a compile time unit, is a compiled unit of compilation, but in Rust it's the complete crate. But yeah, of course they are also applying some techniques to not always recompile everything. Well, for me that's okay.
Okay.
Yeah. So relearn, I started REAPER and I add an instance of relearn. And let's see if the integration tests execute successfully. So here's an action, and this action just executes the tests. So it basically do you see? We still have we still have this listener.
Yeah, our extension is working.
Our extension is working. It's running in parallel, concurrently, let's say that. And and if we wouldn't make it ugly because of these all little messages, you would see like first test basics, second test, it tests NRPN stuff, load mappings, and it runs every test step or every test in a single project tab. So it just uses the REAPER API to execute certain things, and it executed things successfully.
Nice. So very clever idea.
Yeah, it really helped to detect some regression errors, but there could be a lot of more integration tests. Like sometimes I'm too lazy.
Yeah, one can always write more tests, but we only have so much time. I do something similar in my library in JS Effects. I also write this little it's essentially just a text, right? There is this JS Effects that you load into a track and it runs a bunch of tests and prints out the result.
Yeah. However, whatever framework you use, if you build your own one, or it doesn't matter, just execute some things and do some assertions, and that's already super helpful. So in relearn, the tests look like that. Yeah, it's actually part of the main code. Even you at home, even if you could execute it with the official version of relearn. I have a few presets. It's JSON files, and I just load these presets. So there's one test function, and it there I just define the steps. There are some basics. I test here, and I have relearn. I set it up. I wait a bit. I use async await in Rust to do that. I wrote a little executor that for async await that runs on the main thread of Rust. So
it's interesting that async is a keyword. It's part of the syntax, but await is a method you call on the promise, or maybe not a method because there aren't parentheses, but it's not a keyword.
It's a keyword, but they decided to do it like that, so you don't write it in the front. And yeah, the thing is, this is non-blocking. Like the cool thing is that the user interface stays responsive. What happens when you call await is that it defers like the rest of the code and executes it, for example, in the next main loop cycle.
Yeah.
So this is pretty nice. And I can wait, for example, here, send MIDI, and then I wait a moment await. You can do things like that. Yeah, and then I just check if the feedback messages that Relearn produces or the the targets that it changes, if they have the correct value after sending some MIDI messages to it. And in REAPER.s, I have a similar way to test, but I don't use async await. It's more synchronous. So I test a lot of stuff. I use reactive extensions a bit, but each step is executed in each main cycle. So, and I actually tried running these tests recently, and if I'm correct, they are now failing at some point. So I can also demonstrate you a failure. So let's just run them. And it did a lot of stuff. It made it very far. It tested some Unicode stuff. It tested a lot of things, and nothing happened, and suddenly failed. Something about querying the FX floating window has changed. So and when something like that happens, I first have to figure out why is that. Is it because I changed something in the bindings and the API, or is it Reaper that changed with a newer version?
So, yeah, I think that you have more automated tests than Caucus.
I don't know about that, but there are some. I think 130 at the moment. And when I want to know, is it Reaper or is it me, then I go to the Reaper RS GitHub repo and repository and check actions. And I have some continuous integration going on here. And on the Linux continuous integration, the 64-bit one, I do a little bit more. I also run this integration test headless. So here's a test suite. It executes some unit tests. That's not very spectacular. But after the unit tests are run, and I guess that's could be interesting for you at let's check. It actually downloads Reaper from the official site, but a very specific version, like an older version. Then it unpacks Reaper, it installs the plugin into this portable Reaper installation, and I think it starts Reaper with a certain environment variable, and then the extension just executes these tests without being asked, like just at startup time. And here you see the same. It just executes all the tests, and here we can see it made it until the last test. So in this case, I think something in Reaper has changed, or maybe my tests are a little bit too strict. Maybe it's just something changed that is not significant, but I made it significant by having a very strict assertion. Yeah, but this also helps, like having these automated tests headless.
Yeah, this is fascinating. It's a great idea, actually, to download Reaper, run Reaper headless, and have your extension run tests on load. That's something that is quite interesting. I could even, I guess, run this in my JS effects thing, I could download Reaper and have some way of starting Reaper, telling it to create a track, put my effect on the track, run the effect, and then see what comes out. And I could perhaps output the results of my tests as audio, and I capture that. Because I have very limited way of getting stuff out of JS effects, but I have audio or MIDI.
That's very creative as well, like asserting an audio stream.
Yeah. Very clever idea that you have here. Do you have like, there is a cost to creating all these tests. So do you have an intuition of how much time you invested into writing the tests and how much time it saved you?
No. I know that it saved me at some point, and definitely worth it, especially the relearn integration tests are worth it. They already catched a lot of sloppy programming on my side. So I know they are useful, and I know it would probably be really helpful if I write more integration tests. But of course, there's at some point you reach a limit where it's not. I don't write 1,000 tests. That's not so useful.
Yeah, there is a curve of diminishing returns when it comes to tests and many other things in life.
Yeah.
Right. Okay. So anything else that you think we should talk about? Any missing gems in your bindings or in your plugins?
Yeah, well, I could talk about a lot of stuff, but this is so far what I planned to show you today.
All right. Okay. Yeah. Well, we have been talking for more than 3 hours. So.
Oh, yeah. Right.
Yeah. Time flies. Okay. So, should I call you Benjamin or helgoboss? I think Benjamin, right?
Yeah, Benjamin.
So Benjamin, thank you very much for the generosity of sharing your code and explaining all this. And you are so knowledgeable in this whole Rust ecosystem. I really appreciate it. This is stuff that you don't get from reading documentation. This kind of workflows and conventions, and really the nitty gritty when the rubber hits the road is when you start learning stuff. And it was great to pick your brain on all of this. And of course, your extensions are great. People here on the chat are saying, yeah, this looks amazing. I actually need to buy this stuff. And I agree. I think that you should buy Benjamin's software and contribute to his work. And yeah, any last thoughts or messages to people watching?
Yeah, thanks to you, because, and of course also to the people who watch this now. It's great that you joined, and because I'm quite grateful for this opportunity. You know, when you work in a company, you have colleagues, and you talk to them. Sometimes you talk, how would you approach this problem? Or here I've done this, and it's interesting. Maybe it's useful to you as well. And yeah, but all this Reaper work I do at home, there's no one here around I talk to. So that's definitely nice to get an opportunity to talk about it. So very much to you and everyone.
Yeah, well, we really appreciate having you here, and thank you, Fossis and Tail and Bo and Martin and everyone else who is watching this. These are just some names of some people here on the chat. So I look forward to having you here on the stream again at some point in the future to show more things that you're building and how they're coming along. And tomorrow I will not be streaming because we have been online for 3.5 hours at this point. It's crazy. So I will take tomorrow off, but I will be back on Monday, and we will be looking at my probably most interesting JS effects so far. I'm going to revisit that plugin, and we'll be using my JS effects library to re-implement that plugin. So second system syndrome. That's what's going to happen. We are going to revisit that plugin and use the library. It will be great. It's the auto mixer. It's probably my most used plugin. So I'm looking forward to getting back to it on Monday and implement features, fix bugs. It will be great. And that's the show for now. So thank you everyone else who is watching this. Thank you people who support my channel by going to Patreon and PayPal, and also going to Benjamin's PayPal. And again, I said this 2 days ago. Thank you, Microsoft, who became the biggest sponsor of this channel. Biggest one-time contribution from Microsoft. So, and thanks to everyone else. All right. So thank you very much, Benjamin. I see you around, and bye, everyone.
Thank you. Bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.